How are you doing, guys? Good? How about the party yesterday? Was it nice? Uh, was it good or not? Yay, okay, so perfect. Have you had your coffee in the morning? Some of you got it? Okay, lovely, perfect. This is needed for this 1 hour, just to tell you. First of all, of course, thank you for coming to the session. And the second thing is, let me introduce myself, what we're going to talk about today, and what am I doing for a living, and a couple of words, of course, for the introduction. First of all, as you see on the slide, my name is Paula, and my complex surname technically says that I'm from Poland. I always spend really Saturdays in Poland because I'm traveling to different destinations. And basically, what I'm doing for a living is purely security testing. So I'm a penetration tester. That technically means that I'm the person that is responsible for getting into the customer's infrastructure. So this is my passion, this is my hobby, this is my work since right now it's going to be 13 years. And I've been, of course, I've grown up on different kinds of security products and different kinds of security solutions, till, of course, this 13 years ago, I decided to move to one direction, which is the purely testing. I do have access to the source code of Windows, even though it sounds like a small simplification. If it's about the security testing, it's actually very helpful, because this is something that allows, myself and the team as well, to be able to play with the different kinds of security issues. I work for the company that is called Secure, and that particular company is the one that I've established in 2007. And basically, we have developed a little bit. We've got a tiny offices in New York and in Dubai, and of course in Warsaw, where I'm from. And in our team, there is 8 people, including one very smart developer, that we have actually completed the tool just 2 days ago. I will show it on the next session that I have at 1 o'clock. And this is the tool that is actually causing a small break in the operating system, because we have just discovered something nice. And I would like to share this with you today. And that's going to be the first launch of the tool ever. So hopefully you're going to enjoy it. Anyway, for today, what we're going to talk about? We're going to talk about something that is called CSI Windows. So this is the cyber scene or cybercrime investigation scene. And basically, what we're going to be playing with is the areas in Windows as an operating system, so that things technically can hide, or things can, for example, be hiding in a way so that technically, of course, everything is to be found. And I'm going to, of course, make a couple of references to CryptoLocker. That is something that is hitting technically everyone. Plus, I would like to show you the case, because it's a cyber scene investigation thing, where technically there was a malware, or maybe there is still a malware running in a certain computer, and we will need to find out. Too much talking. We will need to find out basically what is the purpose, what's the thing, and what are the details. The whole inspiration for the session comes from the situation that our team has been dealing with a couple of months ago. And that particular scenario was that there was a company, and this particular company was brought down completely, and they just shut down, and they completely had to stop the production. It was actually a factory. And the problem was, and it was quite a big problem, is that this particular company, when the company wasn't operating for about 2 days, which was really the case, technically lost about 4.5 million euros. That's a quite nice amount of money to buy a very good car, isn't it? But anyhow, they were obviously not very happy because of that. Who would be? And they have called us to help out to solve the case, because they have suspected the administrator to be technically sabotaging their network. And as it appeared at the end, of course, this was the case. But to be able to get to this point, we were supposed to do a little bit of investigation of what kind of activities this administrator was making. And based on that, we were able to find out, of course, that this was actually him causing that. So this was an inspiration for the session. All of the tools that I'm publishing, obviously, they are available online, so you can download them from our website, which is secure.pl/tools. There is a tile, you click on it, and then you get to the tools area where there is another link, and then you download the tools. Just a small disclaimer before we start. Obviously, any tool that you run is at your own responsibility. I'm sorry, I have to say it, because some of the tools are quite dangerous. And the ones particularly with the raccoon icon. Raccoon is this tiny animal that, if you are wondering how it looks more or less like on my wallpaper, like this. This tiny one. And basically, whenever there is obviously the raccoon icon, then please do not open the tool in the production environment, because it's going to do some damage, for sure. Yes? So please be careful with that. Just saying, you have been warned. Let's move on. So basically, this is our agenda. At the beginning, we're going to talk about the fundamental research, so the tiny things that we can do if you feel that something happened. And then we're going to move to the live analysis of the situations, because we have one. I would like to show you how this investigation may look like, one of the examples. And then we're going to talk about the system-related mechanisms that are technically used for the malware to hide. And then, of course, we're going to get to the summary. One more thing. Operating system, and this is something I'm completely not a romantic person, zero. And basically, when I'm like analyzing things, I'm always trying to be super down to the ground, and I'm always trying to be very concrete. And whenever we are technically thinking about operating system and this malware hiding or hiding files, hiding data somewhere, there is one thing that it always comes to my head when I'm thinking about this research thing. So I will tell you a small story about my grandfather. And my grandfather, he is obviously from Poland, he's Polish, and I'm laughing a little bit that this is very much the Polish blood, to be stubborn a little bit and to be able to like put things into pieces. And my grandfather is really like that. So technically the story is that not really long time ago, he bought himself a radio. Like we've got in Poland this kind of, we call them Russian markets. So technically you go to the Russian market and you buy a radio for €1, for example, yes? It's very cheap, it works for some time, obviously, not for the lifetime, but what we can expect. So what he did, he bought this radio, and he went home, and he's like, yeah, radio. I'm like, okay. He turned it on, works. Half of success, okay. So he's like, yeah, but, you know, I will need to figure out what is inside. So he took his newspaper, and then he put this radio into pieces, like very nicely placed pieces. He just completely were looking at each piece, like how does it work, what is inside, and so on. So he completely deconstructed it, and then he's like, oh, yeah, radio. And then he constructed it back. And then he, technically turned on, works. And he's like, radio. So basically, the small conclusion that comes out of the story is that if you paid for your radio, how you are not supposed to know how it works. So if you paid for your operating system, it's pretty much the same story. We have put our money into the operating system. And again, this is a little bit Polish approach. I pay for it, I paid for it, I have to know what is inside, yes? It's completely mine, completely, yes? So basically, whenever you've got your operating system, you need to exactly know what is going on inside. How else? How else? So this is what this session is technically about. So whenever we are under attack, something happened, and you are like, I kind of feel something happened, here comes the big thing about preserving evidence. Though this session is not really about that, but this is a pretty important step so that we have something to work on later and to do the CSI thing. So here comes another story with this factory when technically they call us and we are like, okay, perfect, we are coming to the customer side, and the first question I ask is that, where is, of course, could you please give us, because we need to have a material to work on, could you please give us the memory dump? And they are like, the what? And I'm like, yeah, memory dump. After the attack, you make one, yes? And they are like, no, but you know, we had to rebuild all of our domain controllers and we had to like technically reinstall all of them because we had to keep going. I'm like, seriously? So I just imagine one tiny thing. Actually, it was like, oh no. But on the other hand, I was like, that's kind of cool, being a consultant, coming to the customer side, getting paid for your time, and you have nothing to do. So we were like, okay, so what we are supposed to do then? And they're like, oh, wait a second, one of the machines was actually the virtual machine, so maybe we can give you that. And that was actually a success, because out of this virtual machine, we're able to get out the traces of what happened, of course, in the certain situation. It was a long story. We were supposed to actually write the tools for that, because it was really hard to get access to some information from the memory. But eventually, everything is possible. That's why I'm saying that whenever you've got a situation and you feel like something happened, there is one thing that is very good to do, to make a memory dump. And there are different kinds of tools available in the market. A couple of those are free, a couple of those are that you have to pay for them. My favorite is actually the tool called Dump It. So Dump It, very simple, and it's written by my colleague. Unfortunately, it is not a tool that is for free. Don't get me wrong, I'm not advertising anything, it's just a good tool. Though it's quite not expensive, it costs $199 as far as I know. Yes? So this is the best tool to make, in my opinion, memory dumps. But there are also a couple of more. So whenever you are under attack, okay, I understand, you can wipe all the machines, and this is a good practice anyway, not to just sit and analyze, eventually waste your time. We have to keep going, I understand that. But if you want to, of course, make it a case out of that, and if you want to analyze it, making the memory dump, it's one of the most important things. Never shut down the machine. Though in the internet, you're going to find a lot of instructions like that. Shut down the machine. No, don't do this, please, because the whole thing is in the memory. Whatever worked, whatever was done, it was in the memory, or it is in the memory, if the machine is, of course, still running. So just to, of course, mention that tiny part. Okay, so whenever you've got this operating system image eventually, or the memory dump, you can definitely find out a couple of things, what's going on. You can either work on the live machine to do the tiny tests, but definitely preserve the evidence, meaning image the disk, make the memory dump, keep them outside, because everything that you are working on right now, it's affecting how the data looks like. And this is kind of disturbing whenever you are doing the investigation like that. What do I mean by the basic terrain orientation? So that's going to be kind of simple right now, but the basic terrain orientation, if something just happened, is to check out, like, is there anything communicating out of this machine? And of course, you can install Wireshark on this machine, but we don't do that. Yes, that's what I just said. You preserve the evidence eventually, and you work on the live machine. So basically, one of the things that we can do, and this is, as I said, very simple at the beginning, there is a simple command that everybody knows, which is ipconfig, obviously. But ipconfig has this nice feature that is called display DNS. Not the flash DNS, obviously, that we are using all the time, but display DNS allows you, simply speaking, to display all of the things that were queried before. And I got a plenty, because I did not technically reboot my machine. This is my live machine. So what I was communicating with, it's technically there. The question is, for how long these entries are there? Come on, guys, just, yeah, be relaxed. For how long? You know.
Depends on the TTL of each record.
Okay, so the answer is that depends on the on the time to live, so the TTL value. And I guess, okay, you said that as well. Perfect. So definitely yes. So if the hacker would like to, like, for example, have his entry to be valid for 1 minute, it's completely no problem. But what I'm saying, there's always this kind of win and lose thing, like you win, the hacker wins, you win, the hacker wins, and hacker is smarter, and you are like, no, 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 I'm smarter. And hacker is like, no, 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 I'm smarter. And you are like, I'm smarter. And then basically you've got this kind of game. Maybe he forgotten to do that. Maybe. If he didn't, okay, let's move forward. The next thing, obviously, is to check out one more thing. And again, very simple command at the beginning, but that's what we are starting from. It's technically netstat minus ANO. And it will give us one simple thing. So here we can clearly see if there are any processes listening for the communication. So you have established this communication, and here, of course, we got the communication back. So your machine is listening for something, and then it will be great who is listening and how this thing is listening. And the PID, obviously process ID, gives you the information about what this thing could be about. And again, you can be smarter, or hacker can be smarter. Maybe there is nothing listening. Okay, then you conclude, maybe there is nothing. Another thing to check, quite typical thing to have a look at, but not very informative, it's technically RP table. and the error p minus a gives you the information about what are technically the machines that you've been communicating with around. But there is one problem with error p. Error p caches data for 2 minutes, the host is maintained for 2 minutes, and then the next period comes in, which is 10 minutes. And if within this time the record is not refreshed, it's gone. So it's not very informative if you come, let's say, after 1 hour, right? So this is from the network perspective that we can do without installing any tools. But now, here comes a little bit more fun, yes? Because we are like, then what are the things that hacker technically was launching? And let me, of course, move forward to the presentation, and let's discuss how we are able and how we are supposed to search for that. So the typical traces of any kind of activity in operating system, and again, let me repeat, if this is the operating system that you paid for, we have to know what's going on. There are no like secret things. There are no magic. It's just about how deep and how far we go and how intensively we would like to work on it, yes? So starting from the beginning, obviously we've got the logs. Well, today, at the end of the presentation, I would like to show you the tool that we've been working for over 6 months that we will violate integrity of the operating system a little bit. So are the logs trustworthy? In general, they are. In general, they are. But for example, with our tool, they're not. Yes? There was in a Windows XP, the tools, of course, because the extension was different, extension was EVT. Right now, we've got EVTX. And this X, it not only brings XML to the field, but it also brings a lot of more security, technically signatures within the files, signatures of the entries, signatures of the sections within the log. To be able to delete one entry, you really need to struggle. You really need to struggle. So are log trustworthy? They are. They really are. But let's see how the knowledge, of course, and the tool is going to spread. Don't get me wrong, I'm not the evil person. I'm just doing the innocent research. And basically, sometimes this innocent research can hurt someone, of course. Therefore, the dangerous tools, I'm not sharing. And if you want it for the research, I can, of course, share it with you. And technically, you can make a damage by yourself, yes? Okay, so let's move along. Explorer. So what do we see by the Windows Explorer? Obviously, this is our session. And Windows Explorer caches a lot of data. We've got, obviously, things like the run history. We've got also couple of things like most recently used items that saves us the history of the executables per user profile. This is kind of dangerous because obviously, or hopefully, the hacker will delete the profile that he established for himself. If this was about, of course, a new account, then you will not find that information over there because it's not kept globally per operating system, but it's kept per profile. So you have to browse through all of the profiles because maybe someone's password was stolen. I will show you how to do that. Everything we're going to do today, it's going to be with PowerShell. So another thing is the remote desktop connection, obviously. And this is something that is very nice because remote desktop connection, have you ever wondered, like whenever we've got an RDP protocol and you are somewhere in Hawaii and you're like, I would like to check out my email. So you go to Internet Cafe and then you connect technically remotely somewhere, regardless, through VPN, whatever. RDP, it works fast, even if the link is slow. Why? Because it caches the pictures. It does the bitmaps and it saves the bitmaps, it creates the grid, and then it saves them to the local drive in the user's cache. It's actually pretty cool. I will show you how to get these pictures out. And if we are able, of course, to see what this person was technically doing. Another thing, which is really cool, it's the prefetch. So prefetch, it's something that, be careful, it's turned off by default if you are using the SSD drive. If you're not using SSD, prefetch is on. If you've got the SSD, it's off. Turn it on. Why? The case with CryptoLocker, actually at our customer site, shows clearly that it was a good idea to turn on the prefetch. And basically, the thing was that there was one person that clicked on the link, and then obviously there was an executable with the CryptoLocker. This person ran this executable. Now, here comes the question. How do you know in your infrastructure right now if and who there was a certain executable that was launched by the user? Process tracking, we could say. Yeah, okay. Do we have it turned on? You don't have to answer. Yes? Maybe you've got an implemented app locker. Great. Yes? If you do not, how do we know which executable was launched? How do we know on which machine CryptoLocker was launched? We don't. That's the problem. Prefetch will tell you. Prefetch will tell you that. So in Prefetch, you are able to browse through the history of the different kinds of files. Okay, demo time. So the typical traces. Okay, let me move on to the machine. And let's, of course, dig into the whole scenario with the demonstration. First of all, here we go with the machine. Yes, this is the one. First of all, whenever we are thinking about, of course, making the traces, what kind of tools we can use? And answer is, can we use the PowerShell? Of course. But we need to know what to ask for. By the way, this PowerShell script, just don't memorize it, don't write it down. It is available for the download in this tools area that I gave you at the very beginning, okay? So let's just focus on the result and what we can get, and later on you're gonna practice with your script. So basically, the first thing that I can get from the list is the list of the profiles. And let me run it, and let me, of course, enlarge it so that everyone can see that. And the list of profiles, sorry about that. Let me take this out, and let me go back to the machine. And the list of the profiles that we've got is like you see, admin, administrator, Freddy, whoever that is, and some profile that is called public. It's a built-in default profile. Okay, but we are like, yeah, but will the hacker really keep the profile? Of course he will delete the profile. Okay. Then we are technically moving to the next step, yes? Basically, the profile information is stored in the registry. Let me launch it. And basically, whenever it's stored in the registry, we should be able to get access to, of course, all of this profile. Which profile is the administrator's ones? I'm sure you know. You're just shy. 500. Thank you so much. Because 500 obviously is the seat of administrator. Where do we see that? We see it over here, yes, at the end. So this is the end of the seat of the certain account, yes? And we are able to define, of course, what's that. So basically, whenever we are searching for a little bit more profiles, the long ones are the built-in ones. These ones are technically the created ones. So have a look. Why do we have 3 names of the profiles while we have created only admin and only Freddy? Maybe there is something there. Of course there is, yes? Here comes the thing. So basically, whenever we are supposed to list these profiles, we can technically, instead of just listing the profiles, go to the registry and find out the history of the profiles. And now we see another account. Of course, as you see, I created it before, yes? I had a profile which was called hacker. I deleted the profile, but it keeps the history in the registry. So you can always check that out. So the next thing comes, of course, to the field. We can do a little bit more research about that scenario. We've got the most recently used and a couple of other things. So let me run a couple of items. The script is actually pretty long, so you can test it by yourself. And I will definitely recommend it because it's a good information that you will see. Technically, then this particular thing, this item, gives us, so this is stored in a registry, gives us the list of the servers that we've been connecting to. But as you see, from my account that I'm logged on right now, I haven't been connecting to any of the servers. So can we, for example, list the connection list of the certain items for all of the users? Of course we can. Let's do that, yes? So I'm going to technically list all of the other users' history. And then let's have a look. We see here that particularly in this particular case, Freddy was connecting to 10, 10 to 10. And you were like, that's kind of strange. This user was never supposed to do that. Of course, I don't need to remind you about pass the hash, grabbing the credentials from the memory because I've been talking about it last year. But obviously, this kind of credentials being stolen can happen. So this is another trace. Nothing really clearly shows us that something happened. We have to dig in, like completely, this way, this way, this way. We have to do the research. So next thing that I would like to show you, so this is some trace. We'll be back to the server. Next thing that I would like to show you, obviously, I mean, if the hacker was feeling that, I want to paint something in Paint, you can always display yourself the Paint history, yes? But let's say this is not very significant evidence in the whole scenario. Okay, you can, of course, run the recent items that were technically opened. And this is very nice because it also shows you what kind of stuff eventually were launched, were opened, yes? So history by history. But now, let me show you one more thing, the prefetch thing. First of all, prefetch is just a registry entry. Can we see if it's enabled or not? Of course we can, yes, let's do that. And whenever there is a value 3, yes, whenever there's a value 3, like this, then basically it's enabled. Check it out. If not, then just enable it. How to enable it? By changing this value in the registry. It just needs to be 3. 3 means enabled. And by the way, it's kind of funny because that reminds me one thing. I'm always kind of ironic person, actually very ironic, and I'm always like entering this kind of different kinds of administrators forums, yes? And I'm reading all these interesting fairy tales over there, and I'm like reading one of the tips, like I always call it the cheap tricks and tips or whatever, yes? And there is this guy advising the other guy, how can you save the disk space? Very useful, yes? But one of the tips was delete prefetch. Yeah, you just saved like 10 megabytes, congratulations, yes? Deleting prefetch makes completely no sense, yes? Because it's a history of whatever was running. So as long as we know what this is for, there is no point, of course, to act like that. But anyway, let's see what kind of different kinds of entries we can find in a prefetch. So let me run, of course, get child item, so simple. I'm just listing the content of the directory, and I'm seeing over here, technically, the entries representing the executable name that tells me what was running in the operating system. Very good. So if you had a CryptoLocker or someone open any kind of executable, here you will see the history, even though the process tracking is turned off. One more thing, there is a very nice tool, and again, unfortunately, the tool is not for free, but just to tell you, because technically it's one of the best tools in my opinion, the tool is called PF64, very romantic name. Basically, this particular tool, you can get it from TZWorks, and this is the guy that writes the tools like that. The price should be about $100, like that. And this tool allows you to analyze prefetch history. So what is to be analyzed? Well, technically, what it will do, it will go through all of the different kinds of entries, and it will search for, in my case, I'm searching for the Mimikatz, and it will search for how many times Mimikatz or any other tool that you can list will run. And I got a history over here that Mimikatz in this operating system was running twice. What kind of DLLs were loaded? Because as we already know, I mean, executable is one of the forms how we can launch the malicious code. And other forms, I mean, there are many forms, but one of the most popular forms, it's run, for example, DLL through SVC hosts, or run DLL through run DLL32.exe. Yes? Malware doesn't have to be an executable, and this is clear, of course. But how many times this was running, maybe this is the DLL that we are searching for, not an executable, you're going to find this information over there. Okay, so we have found that something was happening, Mimikatz, okay. So if the hacker was running Mimikatz, maybe he got the password of some other user. Maybe he did. Remember this remote desktop connection thing? There was one, yes? Let's see, technically, what happened on this particular place. If this was the remote desktop connection, then we could be like, if this is a remote desktop connection, then it will be great to see the cached data. And don't get me wrong, it's the early cache tool that I've got. My husband wrote it to me because I was laughing that this was the female day, the 8th of March, that we are technically in Poland really celebrating, yes. And normally you buy to the woman the stockings, which is kind of awkward, by the way, but anyway. My husband said that instead of the flowers today, honey, I'm going to bring you a new tool. And I'm like, this is really romantic, thank you. And the tool is actually doing one more thing, and actually a very cool thing, because the tool is decoding. So let me technically load. Oh, sorry. Let me load the certain cache. The tool is decoding the cache from the RDP. So remember, by the way, every time you connect remotely somewhere, you leave the cache locally on this machine. Yes. So even if it's cafe and you are like checking your account status, account balance. Yes, people that are administering this cafe probably will see this, yes? So let me open it, and let me decode it right now. And technically, it looks like this. not a romantic at that time. And the question is, and this is the question to you guys, so that you are not falling asleep on my session, technically, what technically this person was seeing? What is it? IIS, thank you, exactly. So this person was browsing through the IIS console. Yes? Why? We don't know. Let's see. So that's what we're going to do. So let's go to 10.10.2.10. So technically this thing that we've been connecting to. And let's see what kind of changes, and if any, were made to IIS. Let me move to the full screen right now. Oops, no, full screen mode, like this. Okay? And let's see in IIS what do we see. So we've got technically default website, nothing special. We can find out the content view, and there is nothing, Contoso JPG, and so on, some certificates. We've got Contoso files. There is nothing really like strange. So we're like, very, very strange. So here comes the next question. Is it possible that we are communicating with something, we are communicating with the web server, for example, without IIS being installed on the server? Answer is yes. How can we achieve that? Let me move forward. So we are like, it would be great technically to find out if there is something communicating technically with my machine. So the only option that we have is to run any kind of network sniffer so that we are able to find out, of course, what's going on. Let me just run the new capture, like not a big deal. And then basically we are monitoring the whole infrastructure right now. And here comes the thing. We are supposed to analyze what's going on over here, and we can analyze this whole traffic. There is plenty of traffic going on. And technically, there is one communication that means data. Yes? Which one is this? Which communication is data? We are communicating from one side to another one. Probably this one. Yes? We've got a TCP over here. So we are like checking out something, and then we are getting the response back. Why? Let's see. Oh, this is, by the way, lovely. When you see that the process name responsible for that traffic is system. Obviously, it's system. It's self-explanatory, right? But anyway, we are able to find out what's that very easily. Let's see, of course, like if there's any other traffic that we could be worried about. And there is, of course, this TCP going on. Let me, of course, enlarge the whole thing. But what is pretty interesting, and this is like a long, long story because there is a lot of communication going on. With this particular TCP that we have, let me move forward, we can find out the information that the communication happens from the client. Okay, so there is a lot of traffic. Let me move on. And we could, of course, set up the filter, one of the things. And that's what I'm going to do. But this is the communication type, and again, that we've got, of course, moving forward. Another thing that I found that is pretty interesting is the TLS. TLS is, of course, has in a relationship with the communication that is done to the web server. Yes, TLS/SSL. So we are probably communicating and establishing some secure connection. And again, this is triggered by system. What is kind of interesting is that with this particular case, maybe we can find some, like, the traffic being repeated all the time. So, and again, we have to browse. Maybe there is something that is also pretty interesting. So, and so on, and so on, and so on. So there is a lot of communication, as you see, within a certain kind, that technically, sometimes it tells us something, sometimes it doesn't, yes? And in case of this TLS, we have seen that the communication is coming from the client, and it's happening to the server. And again, I'm browsing just like we would normally do that, and we are searching for something technically interesting. We've got some TCP going on. We've got the communication, again, in between the client and and this particular machine, and so on, and so on. We've got this TCP communication. So there is plenty of things to have a look at. Okay, so if there was a communication with the TLS, we are like, is there anyone browsing our web server? And the answer is, let's see. How can we see which processes are responsible for the TLS traffic? And here comes the thing. There is one place like that. What we need to ask, really, I mean, we could use a lot of tools, obviously, but let's understand it. What we are supposed to ask, it's the http.sys. who else, if not this guy, knows the whole thing, right? So if there is any communication that is related to the web, http.sys will do that. What's more, http.sys is responsible for establishing secure connection. Let's see. So basically, let me run cmd. Well, there was already an entry. And I'm going to use the tool that I believe everybody knows, which is netsh. And basically, in netsh, there is a lot of context. Let me enlarge it like this. And there's plenty of things we can choose from. One of the things that I would choose, it's the HTTP. And HTTP, when I run the question mark, it gives me, this kind of commands here, add, delete, dump, flush, and show. And show displays some information. So basically, whenever you are wondering what kind of services on the web level, so technically application layer, are responsible for listening to the web-related communication, you can always do HTTP show, and then, well, enter. One of the contexts, as you see here, it is the service state, this one. And service state will show you all the service state, surprise. So let's get in. So show service state, and it will give you all of the processes that are engaged into the whole scenario. So basically, we can see over here, well, a lot of things. Let me go from the beginning, because it's going to be a little bit more visual. We do have, for example, website contoso.com available on port 443. Okay, so we are listening for the incoming traffic to this communication, to this website. Now, we've got also what is running on the 5985 port. Small tortures before the lunchtime. 5985. 86 is the secure version of it. This is technically WinRM, yes? Windows Remote Management. As we know, this is the service that is based on the web services. So it's listening, yes? So WinRM, it's technically listening through http.sys. Quite interesting. But what are the other things? So technically, let's move forward. We see also, well, as we see some subscriptions, so we are technically listening to what is going on. But we also see something that we don't know, and it's called pricing. It's called pricing. So what is the pricing thing? Like, can I browse it? Of course I can. So let me technically browse it. explore.exe. And let's see what the pricing is about. So it's going to be our local host. And let's browse to pricing. There is like problem with the security certificate. Kind of strange, but on the other hand, it's running on 443. And then it displays as something like that. Am I hosting this through the web server? Answer is no. I'm hosting it actually through one DLL. And this DLL communicates with http.sys to make the service available. And if you're wondering where does this traffic come from, and if you feel it's related obviously to the web services, there is this way, easiest way to check for that. So the next thing, technically, we can move on. And here in the bottom, you've got mentioned process IDs that are related to this traffic. Remember, think system, the process system. It's completely a bullcrap because we don't have things like that. What fits under system is anything that is interpreted by system as an operating system function, like http.sys. That's why it tells us system, but for real, it cannot run through system. It just cannot. So basically, we can check out right now, well, let's say process hacker, what kind of things we can technically refer to. So in here, we can, of course, check out. So this is 972. We've got this process IDs, 972, and I got SVC host. This particular SVC host shows us, well, technically I can go even to the properties, shows us the different kinds of services over here that are related to, well, the service hoster. And not a surprise over here, we've got one of the things, which is a WinRM. We are listening, yes, and this is technically one of the process IDs. Another one was a little bit different one, and it was the 1592. So let's search for that, 1592. This is this one. If we go to the properties, let's do that, we see a little bit more interesting story, which is related to run DLL32. There are two processes in operating system, basically, that never rise like our big attention. Or maybe they do. But technically, we've got SVC host, and we can run, regardless, any DLL through it, or run DLL32.exe, and we can run any DLL through it. So it used to be like that, the developers in the past time, they were using run DLL32.exe to launch the DLLs that they were using through it, yes? Now the times have changed, but still you can find a lot of software that is actually launching the DLLs like that. So remember that in the properties of the DLL, we can find that kind of information. We can find what kind of, we call it an export, so what kind of DLL is there, what kind of function we are technically launching, and what's the export? This is the name of the certain function that we are launching within this piece of code. And in this case, we are running some run CC. There were many kinds of malware in 2014 that they were technically launching itself as a DLL. And if you're wondering, like, oh, what is there anything running? There are no processes, no malicious processes. Of course, there will not be a process because that will be obvious. Yes, it needs to be something deeper. So in this particular case, it is technically a DLL. Okay, so here comes the story. Question is, how do we know what this DLL is doing? How do we know? And answer is, we don't until we check. Yes, everything is just a matter of doing the deep dive. So let me move to the client, because if it's a client communicating with the server, we can technically dig in and also find out if there any other thing, any other process or eventually DLL communicating with the server then. Because the server is listening, the client must be communicating. How to check for that? Well, we could use the Wireshark or we could use the network monitor, well, one of the issues, but in this particular case, client, it's not the web server. So how we are able to search for that? And here comes my beloved tool, which is called Xperf, which you can download from the Microsoft website. And this is the part of the WDK, so the Windows Drivers Kit, one of them. And Xperf, I mean, sincerely, if you want to have the growl of IT, like in your pocket or in your head, learning Xperf, it's really the thing. But then you're going to take away half of my consultancy jobs, okay? So just for you to know, basically, Xperf answers you all of the questions that are related to the infrastructure. Like, seriously. So let's dig in. Of course, end of talking, presentation time. So I'm going to launch, let's say, well, just another command prompt maybe. And then let me go to Xperf. Here we go. And Xperf tool, of course it's a free tool, allows us to find out what kind of processes are causing, well, a specific type of traffic. So what I'm going to do, let me technically paste the command. This particular command, it's with the small explanation, it monitors the processes and threads and relates to it the network activity. And the other things are more just to keep things clean. It's just for the safety so that my file doesn't grow up, yes? But then I will be able, to the bones, to see what's going on. All of the tools, all of them that you are paying for, are relying on something in operating system that is called ETW, event tracing for Windows. And whatever you are using, and it gives you information, there is nobody else to ask. I mean, we have to have somebody to ask. And this thing must exist in Windows, and technically this is ETW, which Xperf is leveraging in the way. Okay, so let's move on. Ah, wow, what a passionate command, yes? So technically, well, what it does right now, it gathers the information. If you leave it like that, you're screwed, simply speaking, because it's going to gather this information in the memory, yes? And then your CPU, your disk, at some moment is going to go high because of the input-output operations. You're going to page out things that you got from where I don't want it, yes? And everything is going to go to the page file. Not a good idea to leave it, trust me. Therefore, we need to stop it. And to stop it as easy as it is, technically, we can stop it just like that, and we can use the Xperf stop -d, and then we can technically use the network ETL file, or regardless, any file like that, that will technically tell us what is inside. So we've got it right now, and now, technically, it's time to do some analysis, yes? And we will need to technically, first of all, convert it to the text file. There are two types how we can convert the ETL file, so event trace log, to the text file. One method is with using Xperf, obviously. Another one is to use trace RPT, and this is the tool that is built in Windows, and it has been there forever. It's a tiny converter built in Windows, just like that converts your ETL to the TXT. You're like, why did tool like that is in Windows? Well, don't ask me. It has been there forever, and we can use it to analyze dumps like that. I'm going to use Xperf for that, and let me do that. And technically, Xperf and then -I network ETL, so input. Then I'm doing the output text TXT, and that's going to be the dumper. Dumper is the converter. Yes, I want to convert the whole information. So that's what I did. And now, let's say find str, and then with ignoring, of course, the letters, the capital letters. One of the parameters that we are searching for is that, and then Xperf knowledge comes to the field, TCP send and TCP receive, because we want to know what kind of guys are sending eventually, making queries, going out from our machines to the world. So here we go. So -I TCP send, like this, in the text TXT. And here we go with the output, yes? I got one thing, it's L something, yes? And then technically, we can search for information. There's also some run DLL, okay. The experience shows that this run DLL on the server was also engaged, so maybe we should have a look, yes? It clearly shows you what kind of guys are communicating, yes? TCP send, another one is the TCP receive. So now we can go technically to the process hacker. If you ask me why am I not using the Process Explorer, no reason in this particular demonstration. I'm using both of them. One is good for one thing, another one is good for the other one. So I'm just using in this particular case, Process Hacker. It's a little bit more colorful and so on, yes? No particular reason in this particular case. Okay, so we've got run DLL, and this is we see the process ID 5112. So we can search for that. Yes, let's do that, 5112. So let's dig in. Aha, okay, we need to sort them. I thought that they were actually sorted. Now they are 5112. Oi, come on. What is it? Ah, okay, the other side. Yes. What is it? No. Do I see the process ID? No, they're hidden. Okay. Just this. In Poland, we call it the blonde factor. But to say it in Norway, it's not very nice, since you got so many blondes. But anyway. Okay, so this is the last one on the list, yes? So here we go. Properties. And we can see, of course, like the whole scenario, that there is also eventually something that is communicating. Now the question is, can we have a look inside? Of course we can. Of course we can. How to do that? Well, as simple as this. You go, basically, to modules. Because if there is an executable, it loads the modules. What are the modules? Well, modules are different kinds of files that are loaded by executable to provide us a function. Yes, so for example, a DLL is a module. So we can have a look like what is running through it, and again, we don't know what we are searching for, don't get me wrong. We are like, okay, maybe I will find something, maybe I will not, yes? So we can browse through all of the modules, and we can find for all of the things that are technically raising our attention, yes? Technically, the one that is directly loaded by this particular run DLL, it's a DLL that is called malwareclient.dll. What we can do, we can go to the certain place, open file location, and then we can analyze it. Eventually, we can analyze a little bit more interesting things. If I will analyze this DLL, it's going to be too easy for this presentation, so let's move forward, yeah? Let's dig in to something that is like a temp file. The temp file, it's a temporary file that is usually created by such mechanisms, and it contains the most up-to-date executing code. So I don't want to have a DLL, I want to have what runs, yes? So this is technically coming from a DLL. So I can technically take this out, open file location, this is the one that I got. So I will just copy it, and I'm going to place it somewhere here to the folder that is called analysis. And now the funny part comes to the field. I can also obviously do the same story with the particular DLL, so I can go to the malware client and also save it somewhere. Let me see, where is it? Here we go. And then I can go to the open file location and then collect simply speaking, the evidence, regardless where is it, yes? It may be anywhere. So I will technically go over there. Yeah, let's go. Okay, good. So there are different kinds of tools that we can use to find out what kind of code is inside. And one of the tools is the PE Browse Pro, one of the available. And you are able to open a certain eventually file. Let me do that, open file. And then we are able to analyze technically what's that. So malware client probably is dropping this TMP file. To be able to see what is in a TMP file, you need to analyze this particular DLL. It takes a while, basically. But here we will see technically if this is like C++ or anything, or this is C# or anything like that, based on the modules that this particular DLL is using. So this takes a moment. I'm going to be back to it because it analyzes the whole DLL. In our case, we are actually using the part of the code is the C++. One part of the code is actually, in this particular case, .NET. So the question is how we can analyze what is in the certain DLL. Let me move forward. I will be back to this because it takes a moment when it runs. One of the tools that I will use here is the tool that is called ILSpy. And ILSpy shows you like exactly what is inside a certain part of the code that runs. I'm not talking about the interpretation of the whole DLL. I'm talking about the interpretation, what is communicating right now. So I can go open, and let's try to load this TMP file. Yes, as you see, it only asks for the .NET assemblies, but I don't want to do it. I want to just analyze this TMP file, and let me open it. Okay, and what am I able to see? It's the part of the code. Like, let's go to the malware client lib, and we can see different kinds of methods here that we technically are calling for whenever we are executing this piece of code. So what we just did, we did technically the small reverse operation, and we are able to see what kind of code inside was executing. So there are many approaches how we can take, but if you ever wondered, what is this DLL doing? This is the answer. Very often, of course, code can be obfuscated and a couple of other things, then you just use the different tools for that, but here we are able to analyze a small part of it. Maybe this will give us a clue. And basically, we see here, as you see, we are decompiling, we are seeing here different pieces of code that, I mean, we will need another half an hour to really analyze that, but this is basically what is launching right now. One of the things that is actually pretty interesting, let me see, check CC, okay, this is the good one. We are here, and let me show you, encrypting something. We are getting key from the server, and we are basically finding out, like, eventually, if there is someone that is getting encrypted, and if yes, then what kind of key? Does this remind you something? CryptoLocker approach, maybe? Yes? So whenever we are using a key that is technically somewhere in the memory, the older version of CryptoLocker has this kind of bug, as we could call it maybe like that you are able to grab from the memory the key, and you are able to decrypt your files. Not a big deal. But right now, how CryptoLocker works is the file is completely removed. You can try to find it though in a memory still if it runs. If it runs, then you can find that. And this particular key is technically on the server somewhere within the Tor network, through the Tor network, on one of the guys that are actually doing that. There is a small change, yes, but you can still proceed with the analysis. And based on that, we are able, of course, to find out eventually what is clearly happening. And of course, we've got this decrypt assembly. We are able to see that we've got some decrypt res, and this particular decrypt res will also, and let's see, it also uses the different kinds of encryption methods to be able to find out and to encrypt eventually some data. So if you've got, have a look, CryptoLocker running, and it's still running, yes, it will maybe have a form of executable, maybe it will have a form of a DLL. If this is a form of a DLL, you know with the expert how to find which particular process this DLL is launched through, plus you are able to see eventually a piece of its code to be able to decompile it and browse through all of the, of course, settings that this particular mechanism is launching. Of course, whenever we are analyzing the code like that, we can get into many conclusions. Effectively, do we have to do this? Well, only if you want to know, yes? But that kind of shows us that we are able to at least understand what's going on a certain host, yes? Okay, so, questions? Okay. Okay. You're fine, right? You're there. Okay, good, good. Yes? Good. So one more thing, yes, because I said that I would like to show one more thing. So this is how we can get to this analysis, step by step by step. Of course, no doubts, it requires this getting deep into the operating system. As I said, grandfather's approach, yes? Let's put it into all of the pieces. And again, what kind of tools I use? There are not many. Xperf was one of them. Network Monitor was one of them. Let's see, of course, the result of the PE browser. Yes, here we can see, and here we go, we can see different kinds of exports, and we've got a run client export. And that particular export, and this is the bad news, we've got technically here a little bit of assembler, which is lovely to see always. But basically, what is my point is that through this particular assembler, you can find out if there is something that is interesting loaded, yes? And you're going to see over here that one of the things, of course, is that we are launching and different kinds of, and here we are loading the methods. Here is some link that we are using. So you can find also within the PE browser a little bit more information, of course, related. You can also see here a couple of more things, what kind of DLLs are also launched through this particular mechanism. So is there any modules, yes? Core main, for example, it's the one that is related and responsible for the .NET code. So that kind of streams you to one of the directions, yes? Because it takes time. So this is technically the result of what we can see. Okay, let's move forward, yes? Whenever we are thinking about like the lock edits and locked cuts, let's see if we can technically do that. In this particular case, I got a tool, and this is the tool that I said that we've been working on for a long time, and this is called EVTX Eater. And let me launch it, EVTX Eater. It looks like this. This was my design, by the way, so blame me if you don't like it. The developer asked, like, what kind of color you would like to have? I'm like, what you're asking? It's obvious, put pink, yes? So that's what he did. The raccoon icon is there, I mean, obviously, because it's quite dangerous. And the question is, of course, what can we do with the whole scenario? But before we move to this whole story, I got the picture that is corresponding to the demonstration, and the picture looks like this. Basically, if that happens, obviously the system gets fully compromised. What I'm going to show you is the thing not to scare you, really. Not to scare you, but just to show you that at the end of this kind of win and lose game, yes, there's always the end. And this particular end, it happens whenever the hackers technically owns our operating system. What we mean by this is that he's able to play with our data so that we can believe in this data. And I'm going to be talking about it extensively on my next presentation. But the thing is that you are able, and let me launch the event log, which is technically over here. You are able, within the application log, let me sort it by, so I got a couple of group policy mistakes, and let me sort it by the date time, so that I am seeing on the bottom, or maybe on the top is going to be a little bit better. Let me do this one more time. We are seeing on the top here a certain events, and we've got today is the 13th, lucky day, 13th of February. So Friday, and let me delete a couple of logs from today. And today, as you see, I got logs that are at 1 a.m. You see that? Let me enlarge it. And these particular logs, what I will do, I will technically delete them. Yes? And this is the kind of new approach to security, because EVT, you can edit as much as you want. But EVTX, it's actually kind of difficult. But what we believe in, it's not always how the things are. And as I said, on my next presentation, I will be showing you a lot of examples like this. This is just one of them. So today is the February, and basically I would like to delete logs from 1 a.m., so let's do that. And it's going to be from 01 to, let's say, 02. Let's do it like this. Yes. And let's see, because the tool is like running on the edge of its stability, because it was very hard to write it. Let's see if technically we can do that. So I'm going to do byte. And this is from 1 to 2 on 13th. That's correct, byte. That's great. Let's see. Affected 2 records. Yes. OK, good. So technically, let me refresh the log, the application log. And as you see, yay, we don't have any logs from 1 a.m. anymore. Yes? So, and again, it's always the win and lose game. Yes? Sometimes we trust the very trustworthy mechanisms like the event log, and I can tell you it's a very trustworthy mechanism because there's a lot of difficulties. But at the end, of course, if the hacker has this knowledge, sometimes it's just easier to wipe the computer out. And if you don't want to create the police case, yes, or you just want to keep going, then fighting and analyzing these kind of things, don't get me wrong, I'm not giving up. Yes, it's very interesting, but sometimes it's easier to not even trust our knowledge, but just to completely wipe the computer out and then set up a new one, because someone may know better. And it's always the risk like that. Okay, let me sum up the whole presentation. So we've been talking about different kinds of mechanisms. Yes, we've got a live analysis situations. We're talking a little bit about the systems mechanisms. So we've got a DLLs, we've got the run32 DLL.exe, and we've got also SVC host through which we can run the different kinds of codes. Of course, we've been playing with Xperf. Xperf gives you the information about everything that is running in the operating system. If you don't know the tool, or you know it, but just a little bit, just get into the subject, because all of the troubleshooting things, including troubleshooting the ASP.NET related cases, with Xperf, it's an amazing knowledge. So at the end, just a small summary. Of course, remember that starting this investigation is a pretty serious step that we are making. You can put the case to the police and make them analyze the situation if it has the business value for you, or you can be like, okay, I'm going to analyze it by myself. At the end, remember that hackers can be smarter. It's not an offense, yes? We sometimes may just do not see things, yes? Things may not be clear, yes? Leaving the operating system like that is never a good idea. Make sure that you're going to collect the evidence. Keep it for the police maybe later, for yourself later, but always make sure that this kind of workstation is never getting to the network. It's always maintained clean, because there's a lot of difficulties and a lot of things where we can launch the code kind of in the hidden way, but for real, as you see, it's not hiding. It's just a matter to dig in. And make sure at the end, and this is the lesson learned, that you've got procedures, like reaction, what to do when things go bad. What I mean is that if you get hacked, what we are supposed to do? Make a memory dump. Okay, but how? So make sure that you're going to keep this document in your IT department so that in case of emergency, you got hacked, they know what to do. Because right now, what I'm seeing at the customer side is always like, yes? So this procedure, 1-page A4 with the steps, which tools, where they are, what to do, would be fantastic. And then your evidence is safe, you can wipe your machine, and then you can move forward to the analysis and scope the problem. Maybe it's scoped to your whole infrastructure, maybe to your own box. It would be great to know, because wiping the whole infrastructure, it's never the case. And of course, we all know that. So hopefully it was interesting. And hopefully you have learned a couple of new things. And if you've got any more questions, I'm here, available. And thank you so much. And hopefully, of course, see you on my next presentation about 1 o'clock. Thank you so much.